Yeah, so we're going to be talking today about uh, trying to optimize Wi-Fi client roaming. It's kind of a tricky topic because roaming is one of those uh, kind of issues that always seems to kind of pop up, show its ugly head, where things just sometimes don't work, even whenever you do the best that you can to mitigate the issues. And it's a fundamental part of Wi-Fi to ensure that the user experience is a good one when they're using the network. So quickly, if I can change the slide, there we go. A little bit about me. I'm a customer support engineer here with Seven Signal. I've been with the company for a little over 2 years now. Most of my experience is on the enterprise network side of things. So I have over a decade now of experience managing, designing, and implementing enterprise networks, from small networks to large global networks as well. So route switch side of things, firewalls, SD-WAN, everything really networking wise I've touched at some point, including Wi-Fi. And I have experience from different industries. So started my career in kind of the energy sector, then moved into healthcare, then decided, hey, let's move into something different. So I've moved into more of like a high density retail environment that also had some manufacturing part of that as well. So, and then as Heather mentioned earlier, I am outside Portland, Oregon, so I'm in the Pacific Northwest. I also have a 1-year-old dog that's kind of to my left of me, sleeping right now. So uh, enjoy going on hikes with him when I can. So quick agenda for what topics we're going to be covering today. So quick introduction into what is roaming, what is client roaming in Wi-Fi side of things. Um, and then kind of talk a little bit about some challenges, some pain points. What are some common issues that users can face whenever they're roaming in a wireless environment, such as like drop connections, where it's moving from one AP to another, slow handoff in that instance, and how those kind of impact the user experience as well. And then talk a little bit about some best practices you can kind of follow to try and ensure seamless roaming. Um, it's sort of like trying to just fix an issue that's always going to rear its head at some point, because clients are the ones making the decisions, and it's hard to force someone to make a decision. But we do our best to mitigate as much as possible. Talk about some security considerations and how those can kind of help ensure your data is protected, help ensure the integrity of your network, and those kind of things. And then also talking a little bit about some solutions that vendors have in place that can kind of help enhance the process, or some things that can help you whenever you're designing your network to try and make it as friendly to a roaming environment as possible. And then briefly talk about some kind of where we're going in terms of like the future of roaming, some things that could be coming down the road. I don't have a lot of experience with these things, so it may just be kind of a collaborative, let's just talk about it in a chat type of thing. Yeah, but definitely highlight some things that could be coming, some things that are here, and kind of if you're interested, things you could research on your own after the fact as well. So quick intro into what exactly is roaming. It's very significant. So it's not just a convenience type of thing. It's a necessity at this point, with how mission critical Wi-Fi is to businesses, especially with now everything being virtual. So Microsoft Teams, Zoom meetings with people collaboratively working. and maybe even moving around an office, being able to roam those devices to a different AP is very critical to the end user experience when dealing with those kind of applications. Um, the core concept of roaming, what exactly is roaming? I was thinking about this yesterday when I was going through some of these slides. How would I kind of explain how Wi-Fi roaming works if I was talking to like one of my nephews or like my mother who has no idea what networking is, how Wi-Fi works, that kind of thing. I kind of came up with an analogy of um, like imagine you have like a backpack or something because my nephews have just started school last month. So like you have a backpack that's magical and has like a toy inside of it that talks to you. Uh, and it tells you all these different like stories and whatnot. But it only works um, if your backpack is like near a specific object, right? So it's like this magical thing, kind of similar to how I think roaming kind of works too. It's somewhat magical in some ways because the client is the one making the decision. So the client's the one that is using a specific algorithm in place. Not a lot of this is advertised, so it's just guesswork in some cases. But going back to that analogy, let's say that as you're moving around with this toy, you're walking around your house, you're carrying your backpack, you get further away, right, from this object, right? And the voice or whatever that's talking to you gets kind of grainy, it gets kind of quiet, and it just kind of to where you can't hear it anymore. But as you're moving, you get close to another magical item that then kind of causes the voice to kind of come back to life. It gets a little clearer, that kind of thing. So it's similar to roaming. So it may not be the best analogy, but I was trying to imagine explaining this to like 5-year-old. So forgive me on that, but it's similar in some ways. So as like a kid's moving around your house with like a tablet or something, and they're on YouTube watching a video, they're going to get pretty annoyed if they're walking around and their video stutters, that kind of thing. Um, Business users are pretty similar. If you're using a laptop and you're on a Zoom call and you're walking around a conference room or you're walking from your desk to a conference room and your conference call drops, they're also going to get annoyed. They're going to in, uh, get a little frustrated that their meeting just got interrupted because of the network. So kind of similar. We want as seamless transitions as possible when it comes to roaming. Um, so you want to go from one AP to another without that interruption, without that unneeded latency. So your video call or your voice call does not drop, does not have a bad experience. And speaking of the user experience, this is where you want your devices to kind of be connected no matter where you are in your environment. So some of those challenges and pain points that we talked about. So dropped connections is kind of the big one. So if you are stuck to an AP, like your client becomes like a sticky client and it's not roaming to another AP, as you get further away from that AP and your signal strength gets lower and lower, your connectivity to that AP is not as solid as it once was. So you're going to start seeing latency issues, a lot of retries happening, and just overall poor connection. Another issue that you can have is that it just takes a long time to roam from one AP to another. So that there's this lag that kind of um, has a delay in the like seamless integration or seamless movement between one AP to another. When that happens, you'll see those dropped connections. You'll see kind of just slow transfer speeds and just poor experience. And all of those can then hinder your voice and video calls. So you can add in latency, like I said, you can add in jitter, and then you'll start missing some of the voice, or your video will start stuttering or just completely freeze, that kind of thing. So in the business kind of world, your productivity can hinder if you don't have a good roaming experience. You can, um, uh, if you have remote workers and you're communicating with someone in the office, and the person in the office is not successfully roaming between two APs, they could have difficulty communicating between each other and just extend out a meeting or cause frustration just because of the connectivity. On the entertainment side of things, so you're streaming your favorite show on your iPad sitting on the couch, and you get up to move, and you have a mesh network at your house, for example, or you have a I don't know, executive in an office that's streaming something on his iPad, and he wants to walk to the conference room, but he doesn't want to stop watching his video. um, you can have some issues there if the roaming handovers don't work as intended. And then IoT and automation type of thing. Let's say you have you're working on an assembly line at like a car manufacturer plant. A lot of those tools they're using these days are Wi-Fi enabled tools, and if they have issues roaming between AP to AP, some of those tools just stop working, and that causes issues in the manufacturing process. It can cause issues in the whole line of the business at that point. And then voice and video is the big one too, because of how crucial it is these days, and how sensitive it is specifically to being sticky and being stuck on an AP and adding increased latency. So some of the tech behind roaming, some at a core, the like I said earlier, the client is the one that is making the decision. So it's the one that's maintaining the connection when it's moving between APs. Um, and then a lot of this is in the 802.11 standard as well on how it works. So when your device is connected, just kind of a brief overview here. The APs will send out beacons, as we know, and then the clients will then send out like probe requests to just see what other APs are around, and then APs will respond to those probes with their own info. So the client will then give its signal strength essentially to all of the APs in the area. So that's kind of how it decides, hey, I'm reaching my threshold. So let's say the threshold for the client is set at like neg 70 dB. That's whenever it starts its roaming algorithm. So once it hits that threshold, then it's going to start looking for other APs to join based off of the RSSI value and some other things as well. So kind of the signal strength quality of the network is at a base level kind of how a client determines what AP to roam to. So you also have to think of like some security considerations as well. So depending on how the clients are authenticated to the network, if they roam to a new AP, it's possible they have to completely re-authenticate to that new AP, which will then slow that transition time from moving to one AP to the other. There are some things you can do to reduce that. So the three big ones that I'm going to talk about are 802.11 K, R, and V. So K is more radio resource management side of things. So that's more trying to reduce how long it takes for the clients and the APs in their scanning time, so they know which APs to join, or have a better idea which APs to join. R is more it's more the fast transition side of things, so it's trying to shorten that authentication piece. in the roaming, and then V is more of like a, I don't want to call it a brute force way of roaming, but it's more of taking the decision out of the client's hand, and putting it into the infrastructure AP side. So the AP will then be the one to say, hey, maybe you should move over to this other AP. Maybe you should go over there, and just uh, kind of shoo it along and corral it into the right area as best as it can. So in 802.11k, so the radial resource management side of things, so this is more to um, try and enhance the efficiency of Wi-Fi networks. So it's giving clients more of um, a better idea of what's in their area. So kind of a quick summary of all the near neighbor APs. So the APs will send out neighbor reports essentially of what APs are surrounding them, so they can kind of get a quick summary of the APs that are near them. And then based off of that, and that could be signal strength, it could be load on the APs. There's a lot of things that can be a part of this. The client can then decide to, excuse me, they can then decide to kind of roam to either a less busy AP or a better signal strength, that kind of thing. It just tries to improve um, the decision making of the AP, giving them the best information possible so they can make the best decision when roaming to a new AP. So it enables it to make intelligent decisions uh, during the whole process, and leading it to faster, more efficient handovers, reducing latency, improving kind of load balancing of clients to APs, that kind of thing, and just trying to enhance the performance of your Wi-Fi network, especially whenever you're in an like a high density environment with lots of APs, lots of devices that are kind of moving very frequently. And then 11R, the fast transition side of things. This is more to try and reduce the overall time it takes for the transition from one AP to another to happen. So there's a pre-authentication, basically, that your device can, you've established an authenticated connection to an AP before you actually roam to it. So you're doing the authentication piece kind of beforehand at that point. So it really lowers the authentication side, that time that it takes for the handover process, which will really kind of go through in terms of minimizing your disruptions, specifically for voice and video calls, and kind of smoothing and try and get that user experience as nice as possible. And then 11V is more is the wireless network management side. So the idea behind this is to more help clients roam to APs. Uh, kind of think of it like you have someone who's struggling to get across the street, and someone just kind of stops and helps them, or someone's just lost and they don't know where to go. So our APs are now going to say, hey, maybe move along over to here. So you're using the network to kind of control and choose where your devices are going. So instead of it's taking that, trying to take that decision out of the client's hands so you can have a better idea of where things are going, that kind of thing. This is specifically good to reduce congestion is a big part of this as well. So if you have a lot of AP or a lot of clients on an AP and they're just not moving to another AP that might be better for them, you can kind of help move them along. I mentioned earlier that I think of this as more of like a trying to brute force your way to get roaming to work as well as possible. So this is really nice, especially in like a large enterprise area or even like public Wi-Fi hotspot areas. So you're just trying to improve the management and the efficiency of the network as best as you can. You want to try and get the control out of the client into your hands so you know and you can kind of predict how things are going to behave, that kind of thing. Um, and then some best practices to try and get as seamless roaming as possible. It comes down to uh, I think everything in Wi-Fi comes down to having a well-designed network. So optimize your AP placements. You want to strategically place them so you're not only providing appropriate coverage, but you're also providing appropriate capacity needs as well. So you want to make sure that you're doing a site survey. You want to do validation surveys. All of that is very, very important. So you want to make sure that you're considering like building layouts, uh, obstacles, wall materials, door materials, furniture that's going to be in the area, number of devices. Is there going to be an area where users kind of group together? And then how are you going to plan for those things? So that's the first key is just make sure you have a solidly designed network. And then you want to leverage those tools that you have. So leverage K, R, and V, so you can implement those IEEE standards to help optimize roaming as much as you can. Use band steering if you need to. Encourage your devices to connect on 5 GHz as opposed to 2.4. In terms of load balancing, um, or sorry, let's fast roaming protocols. So like 802.11r, right? So that's your ally whenever you're trying to quickly have seamless transitions for your users whenever they're roaming between APs. Load balancing. So in terms of like high density deployments, you want to try and distribute your clients or your users across all of your different APs evenly, so you're not overcrowding each other or having very high channel utilization, that kind of thing. You don't want to just step on yourself, so to say. And then you also want to be monitoring, testing. You want to know how your network performs. You want to do roaming tests to confirm that your devices are going to be roaming as you predicted or as you design the network, that kind of thing. Um, Mobilize a good tool for testing roaming. I'm sure Eric's going to show you some things as well on how you can use Mobileye to help look for roaming issues. But there are other devices out there too. If you're using like your Ekahau Sidekick during your site surveys, that kind of thing, you can view it and see how the network is performing as you're doing your site survey. Make sure your devices are up to date too. So whether it's firmware on your APs, controllers, whether it's driver updates, if you have a driver that's causing roaming issues, again, that's on the client side. So you want to make sure that you're not using a driver that's causing inherent issues with the client. Your network might be perfectly configured, but it just kind of making sure things are up to date as much as possible, and then educate your users. This is from a security standpoint, as well as just letting them know, not exactly how things work, but giving them a general idea. I don't know how many calls I've gotten with like Cisco APs, and someone says, "Oh, well, the light's green. Green means good." Well, green means there's no clients connected to it. So just going based off of the light doesn't really tell me a whole lot. Giving them an idea of what could be happening, or being like, "Oh yeah," they just call and say, "Hey, Wi-Fi sucks." That doesn't really help much. So if you try to educate your users as much as possible, it just makes everyone's life a little easier, so they can um, kind of go from there. And then some security considerations to think about too. So even when it comes to roaming, you don't want to compromise on your security. Even if the authentication piece makes the roaming take a little longer, you want to still make sure that you're using strong authentication, whether it's WPA3 or whether it's certificate-based authentication. You just want to make sure that your data is protected uh, from any potential issues, that kind of thing. And then some kind of quick high level overview of some things that vendors can implement as well to kind of help with roaming. Um, so they can have some kind of proprietary roaming algorithms. I was thinking more of like the client side with this, to where a client could be doing some algorithm or something to help them decide when to roam, that kind of thing. A lot of vendors don't publish their algorithms that they're using or anything like that, so it's kind of a guessing game at that point on how a client's making this decision. Making sure that you're using fast roaming. So, like I said, with R 802.11r, um, help just kind of quickly move and transition when roaming as well. Um, some vendors offer some like client steering features as well that will kind of help with that load balancing that we talked about earlier. Kind of reduce congestion, kind of guiding them and say, "Hey, join me," basically. There's load balancing, like I said, so you can have different types of load balancing as well. So you can have APs connected to different controllers, and then having inter-controller roaming happening. You can have yeah, a lot of different things when it comes from load balancing. It's not just balancing the users on the APs. It could be also the backing infrastructure as well. And then intelligent channel selection. So vendors will have algorithms that run to select the optimal channel that the APs need to be on, as well as the power level that they should be on as well. And then it also helps if there's a nice kind of interface for someone to use to kind of find all of this info and configure it. If you have kind of a difficult to use management interface when in terms of configuring things, it's a little harder to find some of those tools, and especially with Wi-Fi. A lot of people that are administrating wireless networks, it's not their primary focus. A lot of these companies, the IT staff is Wi-Fi is just kind of thought on the back end. It's like, hey, just an add-in to other networking tasks. So making it as user friendly as possible improves um, the experience of your end user and the client. And like I said earlier, making sure things are up to date, firmware support, that kind of thing. Some kind of security considerations. So authentication, encryption, you want to make sure that you're using as strong of an encryption as you can. So WPA2 at a minimum, WPA3 now as well. Preventing unauthorized access. So using strong passwords, or better yet, using certificate authentication. Using some type of intrusion detection or prevention will help mitigate those kind of issues. Um, your guest users, isolating those so they're not on your corporate network is a good start. having some rogue AP detection, so you know if someone's broadcasting a network of yours and doing like a man-in-the-middle attack, that kind of thing. Like I mentioned earlier, certificate authentication, continuously monitoring your network, that kind of thing, and auditing your network so you know how things are performing. And then once again, educating your users. Yeah, you're only as strong as your weakest user at that point. So social kind of engineering attacks are still the main way to break into a network. And then some kind of quick high level where we're moving, I think, in terms of roaming, client roaming. We'll see more integration with like 5G. So moving from private 5G over to Wi-Fi, roaming that from one technology to another. I don't have a lot of experience with this, but if you want, you can kind of look up and read a little bit. I think it's called Open Roaming Standard is the one that I'm familiar with. The other one too is like Hotspot 2.0. So those are the two big ones that I'm aware of, at least. And then AI powered roaming. So this is where I think some of vendors actually have already implemented this in some regards, where they're using AI um, to help with that kind of brute force roaming style, to where it's using AI to detect client behavior, and then kind of forcing clients to roam to APs based off of past behavior, based off of machine learning, that kind of thing. And then IoT roaming, similar to the 5G integration. I don't have a lot of experience with this, but it's roaming from either uh, a 5G to a 5G or 5G to Wi-Fi, that kind of thing. I think a lot of this comes into play too with the eSIMs that are getting deployed in a lot of IoT devices. So you can kind of program it onto the SIM networks that you can join. And then enhanced security will continue to get improvements to authentication, to encryption algorithms, that kind of thing. One thing I didn't talk about that is currently in use. I know a lot of retail environments use location services with the Wi-Fi to advertise to their clients specific products. For example, like if you're connected to a store Wi-Fi, as you're walking around the store, as you're getting in a specific area of the store, you can get advertised for products in that area. So you just kind of increasing the ad revenue, essentially increasing the the revenue of the store and kind of generating buzz about an item that may not be uh, something that they consider until they see that ad, that kind of thing. Multi-axis edge computing. So this is kind of getting the computing and networking resources as close to the edge as possible to reduce latency and enhance that user experience. And then zero trust networking. So this is where this is more of a security kind of thing. It's kind of no device is inherently trusted. So you want to do micro segmentation and segment things down in a way to where um, you just assume that everything is kind of evil at that kind of point, and you want to reduce unauthorized access. I don't know how to quickly explain that, to be honest with you. Um, it, it's just very much like a assume the worst, hope for the best type of approach. But it has some merits too, because you're reducing the latency and you're reducing impact if there is um, a breach, that kind of thing. And environmental considerations too. You want to um, have energy efficient tech. You want to make things sustainable. That's where things are going, reducing carbon footprints of the wireless network. It's not something that I think we really consider, but it's definitely where things are moving. You want you want to make things last as much as possible from both a cost perspective, but also from an environmental impact perspective. So, yeah. And then any questions?
Several. We're gonna have to be picky or just kind of pick and choose here. So let's take one from the top. Does OKC opportunistic key catching help with 802.11r?
Um, I don't know how to answer that question, to be honest with you. I will get back to you, Randy, on that answer.
No problemo. All right, let's see. We've got one from Forrest. The AP tells a client, maybe you should grab a different AP. Is there any protocol or mechanism that forces the client to move?
Yeah, so that 802.11v, I believe, is the one that tries to brute force that. So you're trying to uh the AP is the one that says, "Hey, I know my neighbor's over here that has a better signal strength to your client. You should then go over there." It can be done in a few different ways too. So the AP can just de-auth the client to where it loses the connection, and then it forces the client to then try and connect to another AP. But it's also possible that that client just tries to reconnect to the same AP. So again, the client's the one that tries to make that decision. You can try and force it as much as possible. So
Very good. Okay, and we got someone in the chat with an answer to that first question. It looks like OKC is an alternative to 802.11r. So
gotcha.
that's some. Okay, let's see. Let's jump around a little bit. Kind of answered that one. I like this one from Anonymous. Band steer, to band steer or not to band steer? That is the question. Some vendors love band steering while others avoid it. Like a well-known virus. Is it a good idea to enable band steering while using 802.11 or better?
I think that very much depends on the environment. Some environments, band steering is great to use. Some environments, it causes more headaches than it fixes. So it's very much a
It
hit and miss type of thing, like most things with roaming.
Yep.
When the client's the one making the decision, it's kind of hard to to force them at that point.
Yep. Let's see. Forest is very popular with us today. Let's see. We kind of answered that one. How is the ad that came from location-based services seen on a client? Is the person walking around while connected to the store's website?
Yeah, or so I'm trying to think of like a retail store that uses this, but like let's say you're, I don't know, like a clothing store or a shoe store, and you're using the app to maybe you've done some, like you have a shopping list or something like that. You're looking for a specific product. So as you're using their application, they're going to have like banner ads or stuff like that that can then be prompted to you. Or if say they have a maybe it's a very large store and they offer a map in their app for you to know specific items, that kind of thing. They can then have banner ads on top of that. Yeah, you would definitely need to be using some type of either an application that they have or a website that also kind of um, pulls the same thing. But you can kind of group either specific APs or triangulate with APs to know where a user is in the store.